I think an underutilized quality control tool, and I don't know how much it is used in North Dakota, but I always talk about it because I think as an industry we don't use it enough, is control charts. Um, Control charts are a way to plot measurements, the test results that many of you generate as a way to make better decisions. Okay. So here's the way I would say, here's what control charts prevent you from doing. Too many places, and I guess I just ask yourself, is this you either as a contractor, etc., they just react to the last test. Okay. I did a test, it passed. I'm not making any changes. I did a test, it passed. It's getting finer, maybe on a sieve, but it passed, so I'm not making any changes. Test 3, it failed. It's too fine. Okay, too fine on a couple sieves. All right, I'm going to make a change. Right. Okay, I go to the next test. All right, and control charts is a way of combining multiple results together to make better decisions. When you react to just the last test, you have a couple problems. Number one, you are waiting until having failing material to make changes, right? There are ways to find that out before you ever fail, all right? To see trends before you ever fail. Control charts allow you to do that. The second thing that I would say is that you end up overreacting to just chance and random stuff. Okay. You might get a weird result. You make a reaction. You overcorrect, if you will, almost like you do driving. If you go off the soft shoulder, you overcorrect the left. That's a common traffic pattern, right, and cause of accidents that we overcorrect. We can often overcorrect to one result. Control charts prevent you from doing that. Okay. So again, what control charts are, they're plots of measurements or test results, help us identify variation. And what the real purpose behind it is to assign something to a chance cause or an assignable cause. Chance cause is what happens. I said we have variability in our materials, right? We have variability in our process. You go to an asphalt plant facility, I'm pretty sure that you're not going to tell me that it's a tightly controlled environment like it would be in some manufacturing plant somewhere. All right. So our job, especially in quality control, the people who are making the decisions on what to do, on what change to make, right? Okay. They need to know the difference between something that's just something by chance and random, or is it something that it requires me to do something? So again, if you're interested, I actually have a little 2-page thing that maybe I can put into the chat that I created on control charts, and as a contractor once asked me about using them and gave a little guide. But really what they are is you take your QC results. These have to be random results, okay? Randomly generated, randomly sampled results, and you plot them one after another for a given mixture and plant, okay? And you plot it over time. And what you can do is it has statistically derived control limits that are based on your material. They're not in an NDOT spec, all right? They're based upon your material. So you use your own data to create these limits. And what they can is with what they've done, and you don't need to worry about how they got there. But with statistics, they developed these rules of warning and action limits. Okay. Warning limits tell you, something might be going on here. Action says you got to do something. You got to do something right away. Okay. So it helps you determine if your process is under control or is it out of control. The distinction there is under control or out of control has nothing to do with meeting the spec. Okay. Contractor's job is also to keep the process under control so that it is predictably going to meet spec. If it's out of control, then I don't have consistency and it's not going to matter. I'm in trouble either way. So this is an example of a common control chart we talk about for volumetrics. All right. We have the 3 different aggregate gravities that you can have, right? We commonly use GSB, all right, for our calculation of volumetrics and VMA, etc. GSA is when I don't consider any volume of water absorption. All right, I'm sorry, I pointed at the wrong thing. GSB is down here, GSA is no water absorption. GSE is something I can calculate from, it's the effective specific gravity, all right? And so that I can calculate from maximum specific gravity and asphalt content. So what I can do is plot it, and I can calculate it with samples. And what we know is it should be in between these two numbers, and it should be consistent. Consistent, and it drops. What matters here is a change. What I'm looking for is changes. So I have a couple real things of real data, okay? So this is an example of a control chart on binder content, right? Test for binder content, all right? They have their target, which is the green line, all right? They have the mean of their data, all right? Warning limits and control limits. And what control charts have is they have all these rules that you can follow to identify something that I should react to. So an example is one test result outside of a control limit, 3 standard deviations away, okay? That's something that's real. What the statistics are telling you is that's a real problem that's far enough to react to, okay? So I just want to point out the difference here, okay? Here my aim is 5.6% asphalt. That's my target, okay? The control limit is down at 3.4%, okay? So it's saying that you shouldn't overreact to one test even at 4.5. Okay, now this is just example data, right? But what they're kind of saying is at this point, you know something happened here. Something happened here. But if I'm down in this area where my red pointer is, maybe not. Maybe not. Okay, you see no spec limits on here. This is about having a process that is in control, that is around the target and has low variability. That's what a control chart allows you to do. Okay, so and I'm not just overreacting to one test over another. Okay, they have all sorts of different control charts. This is one I also like. This is binder content versus maximum specific gravity. All right, 2 common things that we test for. And what you look for on this one is that it's logical. And by logical, it means the more asphalt I have in a mixture, okay, the more asphalt I put in, the less rock. Less rock means my maximum specific gravity gets reduced. Rock is heavier than asphalt, okay? So this number should go down when asphalt goes up. Opposite. If asphalt goes down, this number should go up. Okay, so it's actually a way that people look at their test results to make sure that they make sense. Okay, so in this case here, okay, the plot, my asphalt content is going down, my maximum specific gravity goes up. That makes sense. Okay, some people use it to kind of diagnose their own testing results, right? So as to not overreact to what could be a quote bad test. Right, a flyer, what other terms that people use to kind of throw out a test, right, which generally we shouldn't do. So I could speak for a long time on control charts. I'll drop a document in here once I stop speaking. If you're interested, you can reach out. These are really underutilized. If any of you perform QC at a plant facility, then I think you should be doing control charts. You know, it used to be one thing when we didn't have software that could automatically do this. We now have software that can automatically do this. Dustin, your question was the x-axis. Yes, that's the number of tests. So what you do is this is my first test, my second test, my third test, my fourth test. All right, these are all randomly done, okay, at the same frequency, okay? So that's a key principle of this. And what you would do is plot the last 20, plot the last 25. There's many different versions of control charts. Some of them have an average, a running average. This is a single test, all right? But I would just plot the last 20 I've done for this particular mixture at all times, right? And so once I get past 20 or 25, this one falls off, okay? But what it's telling me is, again, how this mix is producing so I can make decisions that aren't just sample to sample.